Good morning, everyone. A very warm welcome to present here in the session of Faculty Development Program on Smart Building Design, jointly organized by Department of Architecture and Planning and Department of Mechanical Engineering, NIT Patna. And we are pleased to welcome Dr. Rajneesh, Assistant Professor at NIT Kurukshetra, as our esteemed expert speaker today. Dr. Rajneesh will be delivering a session on the topic of non-conventional air conditioning and approach towards net zero, a subject of great relevance in the pursuit of the energy efficiency and sustainable building systems. And we look forward to gaining valuable insights for his expertise on innovative cooling techniques and their role in reducing the energy consumption in buildings. So now I call Subham Meena sir to briefly introduce the session expert to the participants. Meena sir, please introduce the experts.
Thank you very much, Dr. Ravi sir, and good afternoon, everyone. And it is my pleasure to introduce our distinguished speaker for this session, Dr. Rajneesh, Assistant Professor in the Department of Mechanical Engineering at National Institute of Technology, Kurukshetra. With over 19 years of teaching and research experience, Dr. Rajneesh has been a vital contribution to the field of thermal sciences, renewable energy, and air conditioning technologies. He has spent the last 13 years at NIT Kurukshetra and previously served at UIET Kurukshetra University. His academic journey is completed by his active involvement in research, academic leadership, and international collaborations. Dr. Rajneesh has authored more than 70 research papers in reputed national and international journals and conferences, and has contributed 8 book chapters with publishers like Springer and elsewhere. He has supervised 58 MTech dissertations and is currently guiding 7 PhD scholars, out of which 5 already awarded. Notably, he has organized international conferences in countries such as Singapore, Bangkok, Bali, and the Netherlands. Recipient of the Outstanding Reviewer Award elsewhere 2017 and recognized as a Rosalind member by the London Journal Press. Dr. Rajneesh has also been granted 2 patents by the Indian Patent Officer for his innovations in solar heat collector and dehumidifier apparatus. He recently completed a prestigious SERB-DST funded research project titled Design and Development of Hybrid Powered Liquid Distinct System for Air Conditioning and Freshwater Production, demonstrating his deep engagement with sustainable and energy efficient air conditioning solution. Today, he will speak on highly relevant topic, non-conventional air conditioning and approach towards net zero, where he will explore advanced systems that merge renewable energy, distinct cooling, and sustainable design, offering practical alternatives to conventional HVAC system. Please join me in warmly welcome Dr. Rajneesh to this session. Over to you, sir.
Thank you, sir. Introduce the experts to the participants. Now, once again, we warmly welcome to you, sir, and thank you for joining us. And we look forward for your an engaging and informative session. Now, over to Rajneesh, sir.
Okay, thank you. First of all, Dr. Ravi, for inviting me and giving me this opportunity to share my research in this very important faculty development program on smart building design. And then I would like to thank Dr. Shubham also for nicely introducing me to the participants. So I will share my screen. Is it visible?
Yes, sir, it is visible.
Thank you. So I will be a little bit talking about the non-conventional cooling or air conditioning. That is a step or an approach towards the net zero. And I will be discussing something that I have contributed to this area. Being from mechanical engineering background, I have worked in this area and a little bit in the area of energy and other sectors of the energy like bioenergy and then combustion science, as Dr. Shubham has mentioned in my introduction. So I will be starting with some statistics that this is the energy statistics, and I have taken this data recently from the website of Ministry of Power, Government of India, and this has been quarterly updated. So this data is very important, and this whole game is the game of the energy basically, as we have heard about the various. Uh, we have gone through the like the news also daily. We are having this war between various countries, and that war is the background of that war is basically the power, the energy, and our honorable PM also emphasized uh, in all of the talks about the self-reliant. Okay, so we should be self-reliant, and energy plays an important role to be the self-reliant. Okay, so that is why everybody is running for the energy. So this is the energy statistics. We have total 4.46 gigawatts installed capacity, and center and state they equally contribute to the like for almost 50%, and more than 50, little bit more than 50% is the contribution of the private sector. So if I talk about the sources, which sources have been used for generating the power in India, so you will find more than 50% are from the fossil fuels. Then non-fossil fuel contribution is around 45%. So these details can be like accessed through the Ministry of Power website under the power at a glance sector. So these are the various further resources. The contribution of these sources can be seen over here. So what I want to focus over here is that like we are still relying more on the fossil fuels. So in emissions, if we talk about the smart buildings and if we talk about the net zero, so we should be totally switch to the renewables. We should not touch the fossil fuels, and fossil fuels are also having limited sources. So that is why we should be more and more focusing on the renewables. And these are the Sustainable Development Goals. In September 2015, the world moved from Millennium Development Goals to the Sustainable Development Goals. So in this direction, various countries, they are like especially United Nations, so they are focusing on reducing the emissions, and we have targeted net zero by 2050. So that is why these Millennium Development Goals were defined, and then we moved to the Sustainable Development Goals in September 2015. So the objective collectively was to produce the set of universal goals that may meet the urgent environmental, political, and economic challenges that the whole world is facing. Okay. So these are the Sustainable Development Goals. These are 17 in numbers, and most of us must be aware of these Sustainable Development Goals, though it is just a recapitulation of the SDGs, because these, if we, everybody like the work starts, the charity begins at home, like it is a famous proverb. So everyone has a contribution, everyone can contribute towards the net zero or the sustainability, complete sustainability. So I will just simply read out these goals, and so you can just relate these things with your own life, with your society, with your surroundings, with your professional life also. Okay. So no poverty is the first sustainable development goal, and then second is the zero hunger, third is the good health and well-being, fourth is the quality education, fifth one is the gender equality, sixth one is the clean water and sanitation, seventh is affordable and clean energy, eighth is the decent work and economic growth, ninth is the industry innovation and infrastructure, I think this must be the relevant one to this FDP, though every goal is connected towards the sustainability. So 10th one is the reduced inequalities. 11th is the sustainable cities and communities. This is also a little bit connected to this the theme of the FDP. 12th is the responsible consumption and production. 13th is the climate action. 14th is the life below water. 15th, life on land. And 16th is the peace, justice, and strong institutions. 17th one is to get the partnership for the goals, to have the connectivity between various contributors, and to achieve all the above mentioned 16 goals. Okay, so the 17th one is the collective efforts. Okay, so that is why India is also contributing towards achieving these sustainable development goals. So these are the few of the initiatives and contributions that NIT Kurukshetra and my team specifically is working in these areas to contribute towards the sustainability. First one is the bioenergy sector. In this, I have been taking these projects or challenges in the areas of anaerobic digestion and gasification. Second is the solar energy. In solar energy, we are working in solar air conditioning and solar heating. So I'll be talking about this solar air conditioning today. Third one is the hydrogen energy. Its utilization part I'm looking after only because hydrogen has mainly three challenges. First is its production, second is its storage, and third one is its utilization. So particularly we are doing work in this area of utilization of hydrogen energy for the combustion of IC engines. And of course, we are promoting the usage of renewable energy sources to achieve comfort conditions and for transportation and power production. And through various workshops, conferences also we are organizing. And we are of course giving the some workshops to the summer internship students also. Then sensitization about the usage of biodegradable packaging and segregated waste disposal. And we are aware people, like I have been approached by various farmers and nearby villagers to get more knowledge or insights for the usage of crop residue for the anaerobic digestion process or gasification. Like various ways are there in which we can just utilize this crop residue. And we, especially Haryana and Punjab region, we are contributing to this pollution, specifically at the time of crop harvesting season when they burn the crop residue. So there are so many alternatives, and we have done a little significant work, I can say, in this area. Okay, so if I talk about the conventional energy crisis, so in India, the energy demand increases at the rate of 6.5% per annum, while the crude oil demand for the country that is met by imports is about 80%. So 80% of the crude is being imported from the other countries. Even we are not having the good quality coal also, like as I mentioned in the introductory slide, that more than 50% of the power is being produced from the fossils. And fossils, coal plays an important role. So we are not having a good quality of coal in India. That is also imported from nearby countries. And therefore, energy security becomes a key issue for the nation as a whole. Okay, so that is why there is like a war-like situation amongst the neighboring countries also. So air conditioning also has contributed towards the carbon emissions. So 7% of the global electricity is being consumed for the comfort conditions or for achieving air conditioning. Then 3% of the carbon emissions are from the air conditioning. If we go for the course, majorly we go for the conventional air conditioning. Conventional means the vapor compression systems. So mostly vapor compression system, they are running on the compressing compressors run by the motors, and motors are being operated with the help of high grade energy, that is electricity. So there is a panel, the Intergovernment Panel on Climate Change (IPCC), which includes more than 1,300 scientists from the US and other countries. They have forecasted a temperature rise of 2.5 to 10 Fahrenheit over the next century. So this is also because of these activities that we are doing for getting the comfort conditions, or to talk about the power production. So comfort conditions can be achieved only because of the power production if we are aware of the availability of power. Okay, so power majorly I have gone through the statistics. We have just gone through the statistics. So what is the solution? So little bit contribution that I have already discussed. So the energy crisis has triggered the awareness to find an alternative energy. So we are already aware of the alternative sources, okay, which comes from natural gas, renewable energy, hydrogen fuel, bioenergy. Okay, there are so many types of renewable energy sources. We are already aware of those. The thing is to implement these and to get the proper utilization of these renewable energy sources. So we should have some plans. We should have some schemes. So some frameworking should also be there by the governments to implement. We have actually done a lot of research, but this research is still 80% of the research is in still papers. So we are not working actually. And if I talk about my office only itself, so though we have developed a non-conventional air conditioning system, but still I am using the conventional air conditioning system because this idea has not been adopted by any industry. That is why this is not a like ready to use what you call the product, commercial product. So that is the gap between the companies, industries, and academia. And for you can say the research work is still in the papers. So that is why that gap has to be filled. And in India specifically, we are having this gap. A huge gap is there in the industry and the academia. So the proper planning is required to utilize these sources in most sustainable way. So there should be proper frameworking and implementation of the policies which promote the use of these energy sources. Okay, so the most important thing is the frameworking and implementation of the policies. Okay, so coming to the cooling and air conditioning. So cooling is a process of lowering the temperature of the system below the like atmospheric temperature, that is cooling. And if we go beyond 0 degree, so it is known as refrigeration. And air conditioning is little bit different thing. So air conditioning means we have a specific conditions, comfort conditions defined by ASHRAE also, American Society of Heating, Refrigeration and Ventilation. Air conditioning engineers, and in India we follow the ISHRAE, Indian Society of Refrigeration and Air Conditioning. So air conditioning means we are having specific conditions like that temperature you might have observed. It has been written over the ACs nowadays 24 degrees C and 50% relative humidity. Okay, so these are the primary prime properties of the air that are to be maintained for filling the comfort conditions. Okay, so that is the air conditioning. So to achieve these comfort conditions, we have in general the vapor compression system as a like to achieve this air conditioning. Okay, but there are certain other methods also to achieve the air conditioning. I will be discussing about those other alternatives. So these are the mainly we can in non-conventional systems we can use in place of the high-grade energy electricity, we can use the low-grade energy, that is heat. And heat is abundantly available in like most parts of India. If I talk about India in specific, we have more than 300 clear sunny days in India around the year. And most of the parts we have good direct normal irradiance. We have the good availability of solar energy, so that solar energy can be utilized for achieving the comfort conditions or air conditioning. So basically, we need some energy input to get the desired output. That desired output is the refrigeration effect or the cooling effect. So that energy may be in the form of electrical energy, but high-grade energy. So most of the conventional systems like vapor compression. So vapor compression systems, they are using the electricity, but in place of electricity, we can use the heat energy as a source of like energy. So that will drive the system to get the cooling effect. So cooling effect is like if we are going for the simple cooling, then we can just lower down the temperature of that object or the space just below the atmospheric conditions. And in case of air conditioning, I have already discussed about the air conditioning concept. In psychrometry, psychrometry is the process where we deal with the properties of the air with respect to the ambient conditions. And in particular, we are concerned with the temperature of the air and how much is the moisture content in that air. So that will collectively give you the comfort conditions. So these are the two main important parameters. So this is the basically the mechanism in which we can just use the heat source to derive the system. If I talk about the specifically the solar cooling, so solar cooling we have the main classification as is shown here. In solar thermal cooling, we have two main systems. One is the open system and another is the closed system. So if I talk about the conventional system means like vapor compression system, the ACs we are having in the offices and houses. Okay, so these are the like the system is running in the closed circuit. The refrigerant flows in a closed circuit. Okay, so refrigerant uh, like goes from the one component to the another component. There are mainly four components in any air conditioning or refrigeration system. Evaporator unit. In evaporator unit, the refrigerant picks up the heat from the space which is required to be cooled or refrigerated, and the phase of the refrigerant changes from liquid to the vapor. It will have the kinetic energy and it will move fastly from that place and it will pick up the heat from the space to be cooled, and then it will be going to the various phases. It will be required to be regenerated, or you can say like it has to be charged again to come back and pick up the heat. So it is basically picking up the heat from one place and delivering it to the atmosphere. Okay, but it is going through the closed loop. It is not going into the like a direct contact to the atmosphere. So in the condenser unit, the heat is being liberated to the atmosphere. You might have seen the indoor and outdoor unit in case of split AC, and in case of window AC, we are having the half portion is goes inside the room and half more than half is going outside the room. The separation is through the wall. So this procedure is same actually. This is a closed cycle. So in solar thermal cooling also we have closed cycles and open cycle. But open cycle is not possible in case of conventional air conditioning systems. So closed cycle we have either we can go for the vapor absorption cycle and another we have the vapor adsorption cycle. Vapor absorption we can have water lithium bromide absorption system or ammonia water absorption. These are the two famous systems. Otherwise we have other combinations also. And in vapor adsorption there is a like important technique that is known as desiccant technique, solid desiccant peel. If somebody is from mechanical background in this workshop, they must be aware of the desiccant technology. So enthalpy wheel, it is also known as enthalpy wheel. It works on the principle of adsorption in place of absorption. In open cycle, we have the desiccant cooling. Again, we have solid desiccant and liquid desiccant. So we have these solid desiccant systems in both ways, either in open or in close. Okay. So we have worked in this area, discussing a little bit about the work that we have conducted. We have done at NIT Kurukshetra. So first of all, what is desiccant? So desiccant is a material which absorbs moisture from the atmospheric air. It has affinity with water. Okay, so like in a daily routine life, you might have seen the small pouches of like some pouches are there placed in the crockery or shoes. So those pouches are having the silica gel. Okay, so silica gel is a desiccant material. When it comes in contact with moisture, it will absorb the moisture, okay, from its surrounding. And if we expose it to the sunlight or heat, it will be like the water will be released. So it will be again generated or regenerated, and it is again activated so that it can be used again. So its absorption capacity is more when it is at lower temperature and decreases when temperature increases. So that is its capacity also varies with respect to the temperature conditions. So when exposed to sunlight or heat, it releases or the adsorbed moisture, the moisture that it has absorbed from its surroundings. It will be released to the atmosphere when it comes into the contact of sunlight or heat. So desiccants are basically in two forms are there. One is liquid form and another is solid form. In liquid form, the like mostly used liquid desiccant materials are lithium bromide, lithium chloride, and propylene glycol, calcium chloride. Also, we have done some experiments with calcium chloride. So, and in solid form, we are silica gel, activated alumina, activated charcoal. So there are so many other forms also. Within the solid form, we have other materials that can be used as a as a desiccant material. This is just an overview of the process, how various methods. So mainly we have open cycle and closed cycle, and which we talk about the closed refrigeration cycle. We can use the chilled water as a working fluid, and in liquid phase, if we talk about the closed cycle, we have both solid materials and liquid materials. In solids, we can use silica gel, ammonia salt, and in liquid, we can use water and lithium bromide as a mixture, or what you call the solution, the desiccant solution. So pure solution cannot be used because it has so many challenges. When we mix it with water, so it releases the heat also. So that is why practically there are so many challenges which I will be discussing about these challenges in the subsequent slides. Then, okay, so adsorption chillers are available in the market, ranging from 50 to 430 kilowatt. If we talk about the solid sorbent again is can be used. The desiccant can also be termed as sorbent which absorbs the moisture. Okay. Then ranging from 20 kilowatt to 5 megawatt, 5 more capacity. COP is also a little bit higher as compared to the solid ones, 0.6 to 0.75. For single effect, we have double effect also. I will be discussing the single effect and double effect systems. Temperature, the driving temperature is 60 to 90, and in this case, we have 80 to 100 degrees C. We'll be discussing about these things. What is the driving temperature? How much is the absorption capacity? Which one is better, liquid or solid phase? So likely in the open cycle, we have all the things available. In open cycle, the COP is little less, 0.5 less than equal to 1. It is okay. Temperature range is 45 to 95 degree and 45 to 70 degree in case of liquid. Since the regeneration temperature required is little bit less as compared to the solid ones and the closed system cycles. So these are the absorption systems. What is the working principle? So this is the driving heat going into the desorption. Desorption means we are releasing the water, moisture. So water is released, then condensed, then heat is rejected. Like in this case, low temperature heat, we will have the water will be evaporated, and then it will be absorbed, and again the heat will be rejected. So we'll understand these things with the help of some animated videos. So this is an open cycle desiccant cooling system. So the components and overall systems, they are available in market, and practically they are applied since so many years. About in worldwide, if we talk about Japan, US, Sweden, Germany, and in India also they are available. So we have the in-house indigenous manufacturing of these desiccant cooling systems. Alternatively, periodic system with fixed bed dehumidifier, they are also available. The driving temperature less than 45 degrees C is also like less than 45 degrees C temperature. We can work with these cycles. So this much at low. This is a very low temperature, and this temperature can be used to regenerate the liquid desiccant material. Okay, so the purpose is to get the regenerate the desiccant material, and if we have the regeneration temperature less, so it means the energy input is a little bit less. Adiabatic dehumidification process in sorption rotors and cool dehumidification in fixed bed processes. So these terms will be discussed. And this is the concept of desiccant wheel. So this is a heat exchanger wheel, and this is a desiccant wheel. So air is supplied from this side. Okay, so this is the atmospheric air, suppose, or if it is a closed system, then the same air is being returned and going through the desiccant wheel. So half portion, the above half portion of this desiccant wheel works as a dehumidifier, and lower portion works as a regenerator. Regenerator means we are releasing the moisture from this desiccant wheel. The moisture that was absorbed during this process was released in during this. The wheel rotates actually. Okay, the rotation is very it rotates at very slow, less RPM, so that it slowly uh, takes up the latent load. In air conditioning, we are having basically two types of loads: sensible load and latent load. Sensible load means we are having the thermal load, heat. The temperature is required to be lower, and latent means we need to remove the moisture as well. So in the upper half, the moisture is being released, absorbed from the atmospheric air. Now the air that is coming from the upper part of this desiccant wheel is now a little bit hot and dehumidified. Okay, so moisture is taken up by the material, we have the silica gel coating over the honeycomb structure within this wheel, which is known as desiccant wheel. Okay, so the moisture is taken up by this wheel or the silica gel coating. Then the air that is coming out of this desiccant wheel is now a little bit hot and dehumidified. Now, hot and dehumidified is again not a comfort condition. Okay, so we need cool and dehumidified. Okay, but some moisture content should always be there, like as I mentioned about the comfort conditions. It should be the temperature should be around 24 degrees C, and moisture content, relative humidity should be 50%. Okay. Now there is a heat exchanger used in this process. Then in heat exchanger, the thermal energy, that heat is also increased. That heat will be taken up by this again, a, a, a wheel type of heat exchanger. Okay. Then this heat will be utilized in the lower portion to again regenerate the what you call the desiccant. Okay, the desiccant, this lower portion of the desiccant wheel requires more heat energy to liberate the moisture from the adsorbed what you call the desiccant material. Okay, so sometimes additional heater is required to achieve that regeneration temperature. As I mentioned in the previous slide, that regeneration temperature 45 degrees C is required only for the liquid desiccant material to get regenerated. So that is the kind of limitation of the solid desiccants. Like we need more temperature to get the desiccant regenerated. Okay. Now we need to increase little bit moisture of the air, as this most of the moisture is taken up by this desiccant wheel. So to get the comfort conditions, we need to little bit add moisture. So for that purpose, we are using this evaporative. Okay, so in evaporative cooler, like a desert cooler, we use the households. So little bit moisture content will be increased, and ultimately at 0.9 we'll be getting the comfort conditions. So after that, the same air in the closed system, if it is a closed system, the air will be returned back to the cycle system. Okay, so this whole cycle is completed. And this will try to understand over the psychrometric chart. So there are different systems. This is a ventilation cycle in which the fresh air is also used. So the people from mechanical background, they will understand the psychrometry. This is a psychrometric chart. On this side x-axis, we are having the dry bulb temperature from 0 to 60. In this case, it has been shown. Though practically we have little more temperatures. So, parallel to this line, we are having the relative humidity lines. In this direction, as you can see the movement of the cursor, these are the wet bulb temperature lines. So in actual, there is a complete graph which is known as psychrometric chart. So there are different terms also. So in ventilation cycle, so this is kind of the previous system you can see, but the direction is. Is there any query? Am I audible?
Yes, sir, you are audible. I think it's some interruption from the
Participant side.
participants.
Okay, no problem.
Yes, sir, continue.
So this is a desiccant wheel, R and D. So this is a wheel, half portion, the above half portion acts as a regenerator, lower half portion acts as a dehumidifier. So air is supplied at this point, 6 point. So we'll understand this process on the psychrometry parallel. So air is being supplied to the desiccant wheel. Okay, so this is a desiccant wheel. Now what desiccant wheel does, it will remove the moisture from the air, that is atmospheric air, which is like in rainy season we will be having uh, more humidity in the air. Okay, so we feel too much uncomfortable. So that is the latent load that is required to be taken up by the air conditioning system. Now this dehumidifier will take up the latent. Now air that is coming out of this dehumidifier will be little bit heated, but the moisture content will be taken. Now you can understand the moisture content goes up in this direction. Temperature goes in this up in this direction. So temperature is increased, but moisture content is temperature is increased, but the moisture content is totally decreased. Okay. Now it is passed through the heat exchanger where it goes through the sensible heating. Okay. Now cooling, sorry. This is a sensible cooling. 7 to 8 is a sensible. If we are going against this arrow, it means this is the cooling, sensible cooling. There is no change in the phase of the process, the working fluid, and that is why it is known as sensible cooling. Then it is being passed through the evaporative cooler. Again, as I mentioned, to get the comfort conditions, we should have the proper moisture content as well as the temperature should be maintained. So it will pass through the evaporative cooler. Now, little bit moisture is increased. Okay. So now we have got the conditions close to comfort condition. These are the comfort condition: 50% relative humidity and about 50-degree temperature. So it will be gone to the room, and where it will take up the latent load as well as the sensible load. Okay. Where if the occupancy is more, we will be having more latent and more sensible load. Okay. If there is no occupants are there, so maybe sensible load may be there because of the some electrical appliances are continuously lying in the offices or rooms. So there will always be a sensible load. The heat gain will always be there from the walls of the room. And if there are more windows, so more heat will be coming into the room. So that those things will should have to be taken into account for designing the system or for coming to the calculation of like how much tonnage of the refrigeration is required to maintain the comfort conditions within that room. So these are the factors like how we calculate the load. Okay, like this much is the load of that room, this much is the occupancy, these are the fixed electrical appliances. Okay, this much heat will be gained from these walls. How many walls are directly in contact with the sunlight? How many glasses are there? How much glazing is done? Okay, how much is the glazing? Okay, or covered? How much is covered and how much is not covered? How many walls are there? So these are the factors that will uh, that are taken into account while arriving at the like capacity, the cooling capacity of the system that is required to be deployed in the room to be air conditioned. So after that, it will again go to the sensible heating. Now the heat that was being given to the heat exchanger will be utilized. Same heat will be utilized to this heat exchanger, common heat exchanger, since we need again heat to regenerate the desiccant material. The desiccant material, the desiccant coating that we have applied over the enthalpy wheel or the desiccant wheel. Okay, so this is the sensible heating, 2 to 3. Then we have applied additional heating from 3 to 4. Okay, additional heater, sometimes it is not required if we have the sufficient temperature. Then the desiccant that took up the moisture during this process, that moisture is required to be released. And that is done with the help of this heat that we have supplied during this process 4 to 5. Okay. So the outdoor air is dehumidified and cooled. These are the that is the purpose basically of the any air conditioning system. And then humidified before being introduced into the conditioned space, and with the help of additional evaporative cooler, as I mentioned. So the desiccant wheel absorbs moisture from the incoming air and increasing its temperature. Little bit temperature will be increased because of the moisture has been taken up from the air. So that is why the temperature is little bit increased. The air is then cooled through a heat exchanger using the cooler return air. Finally, the air is humidified, reducing the temperature, and then it is delivered to the space. Then it is a ventilated recirculation cycle. So these are the various cycles that have been adapted, and like many people are still working on various combinations, like from here or there, how much air is should be supplied and what additional things can be done, additional changes can be done to improve the system's efficiency or effectiveness. This is the enthalpy wheel or desiccant wheel. Upper half acts as a regenerator, lower acts as a dehumidifier. So this air is taken back to the again to this supply. Okay, so that is the change only in this cycle. So the process air that is required to be cooled is a mixture of fresh air coming from the ambient and recirculated is air is coming from the conditioned space. While the regeneration air used to regenerate the desiccant is also outdoor air. So this cycle offers a balance between the energy efficiency of recirculation and the benefits of using fresh air for ventilation. So that is the additional feature. So rest of the cycle is same as we discussed in previously. The processes can be seen on this psychrometric chart as well. Likely there is another cycle which is known as simple water sensible heat exchanger cycle. So there is additional heat exchanger, two heat exchangers have been used, and the cycle can be understood with the help of psychrometry. In this cycle, water is used to remove the heat from the air and transfer it to a location where it can be more easily dissipated. So this cycle often involves both dehumidification using a desiccant to absorb the moisture and evaporative cooling is also used. Evaporative cooling is always used in these cycles. So this is again another mechanism uh, devised by this, which is known as ventilated.
Hello, sir. Can you hear us? I think your video is stopped and your voice is not coming. Rajneesh, sir, please try to present again. Your screen is not visible to us. I think there is some kind of interruption in network.
Yeah, is it visible? Am I audible?
Yes, sir, you are audible and your presentation is also visible.
Okay, thank you. So, I was discussing about these configurations. So can you confirm whether I have discussed this slide or not?
Sir, this
Okay,
slide
I'll
is
discuss.
not been discussed. You have
Okay,
discussed till slide number 21.
okay, okay. Thank you. So I was talking about the different configurations that can be used in desiccant technology, desiccant cooling or desiccant air conditioning. So this is the pack bed system, which the system that we discussed in the previous slides, that was a desiccant wheel in which a honeycomb structure is used and over which this silica gel coating is provided, and that silica gel acts as a desiccant material, solid desiccant material, which absorbs the moisture. So likely in this case, we can use a packed bed, and like a similar structure, like a honeycomb structure, coated structure can be used, and air is being passed through these honeycomb structures, and the moisture can be removed from uh, the air, that is the ambient air. And the desiccant solution is usually distributed from the top of the bed and flows over the packing, where it comes in direct contact with the, okay, this is a similar one to the desiccant. Now this is the liquid desiccant. In liquid desiccant, the solution is solution of the liquid desiccant, like mixture of water and the desiccant. It is known as a solution, desiccant solution, which is distributed in general from the top of the bed and flows over the packing, where it comes in direct contact with the air, and it removes the moisture from the air. And the solution is collected in the basin. So this is the solution collected, and it is falling from the upper side. Okay, so these are the solution droplets falling over the packed bed packing, and the air is being circulated in the counterflow direction. And the main problem is of the pressure drop, and another problem is the carryover problem. Okay, so as the air has to work against some structure, okay, some obstruction is there, so there will be a pressure drop. We will not have the sufficient flow rate of the air at the outlet or the supply air. The thrust, we talk about the thrust. How much is the air thrust of a particular air conditioner? Like up to where, what length can be covered through the cooling air stream. So for that we need more input, more energy input will be required in that case. Okay, so that is a pressure drop will be there. Okay, and then another term is known as carryover problem. So carryover problem is the problem where the solution, the desiccant solution, will goes along with the uh, air. So that is the air will take along with it the uh, desiccant solution. So that is known as the carryover. So we have tried to minimize these two problems with our system, and we have got the patent on that system, as Dr. Shubham has mentioned in my introduction, that I have got two patents granted. So one of the patents was based on this technology only. Likely we have the another configuration which is known as spray tower. The spray tower, the desiccant solution is spread as a small droplets from the distributor, like in a vapor form or the mist form, and the air comes in direct contact with this desiccant solution droplets. So the air is in direct contact, so there are more chances of carryover problem. Okay, so the configuration is almost similar. We can just reduce the temperature by employing a condenser unit, where the additional heating is being done altogether. So Another configuration is the falling film, where the film is passed, the desiccant solution film is distributed over the plates, or sometimes we can use the tubes also, and the air flows over this solution film. So almost same principle we have used, but in this case the plates are in vertical direction. But in our case, we have kept the plates in horizontal direction. Okay. So it experiences lower air side pressure drop compared to the packed bed. Of course, this is better configuration as of the previous one, and lower risk of desiccant droplet carryover. Okay, so carryover problem is also a little bit reduced. So we have used the combination of the previous one and this one. Likely there is another configuration which is known as membrane based. So air and solution streams flows in alternate channels which are separated by microporous semi-permeable hydrophobic membranes. So hydrophobic. So that is why this concept is also little bit utilized. We have used some specific mesh uh, that is placed over the flat acrylic sheet, and that is kept horizontally. So we will be discussing those things with the help of some photographs. So what are the advantages of desiccant cooling? We have the better indoor air qualities since the latent load can be totally taken up, and it is the latent load which it is the moisture basically which grows, the bacteria grows rapidly in the moisture rich air. So that is why we have got the better air quality and allows fresh air and disinfects the air. So if we have the fresh air after every charge, so it is not being circulated as in the case of conventional systems. In conventional systems, we just recirculate the air. It goes on passing through the evaporator unit again and again, and the same air is being recirculated. But in case of open system, we can just we can have the ventilation cycle also, as we discussed previously. So those psychrometric chart processes, the processes that we have discussed on the psychrometric chart, they are applicable to both the solid as well as the liquid desiccants. So energy saving and low maintenance, as I mentioned, they are operated at with the help of low grade energy, that is heat energy. Heat energy is required to regenerate, and though some pumping is required, so pumping is the requirement is very less as compared to the conventional air conditioning system. So they can save up to 25%, 25% energy for humid climates. So there is no danger of ozone layer depletion since we are not using any CFCs or HCFCs or any other commercial refrigerants in the system. So we are simply using the desiccant solution, which is having no impact on the ozone. Since desiccant system operate at near atmospheric pressure, so the construction and maintenance is also simple. As I mentioned, the conventional systems, they run on the vapor compression. So compression is there means we are increasing the pressure. So high pressure system is there, and it goes from one phase to another phase, the refrigerant. So there are chances of leakage also. There is a high pressure system. Okay. So that is why the system is little bit complicated as compared to the our non-conventional system. It can be used for summer monsoon air conditions as well as the winter heating, when regeneration energy can be used for the heating. Okay, so it can work like the all-weather air conditioning systems that are available in the market nowadays. Okay, so it can work in for the like cooling as well as for heating. Like the people from mechanical background, they must be aware of the difference between a pump and refrigerator. So the difference is only of the which output you are focusing on, either the refrigeration effect or the heating effect. The heat energy, the work input will always be there. If we are having the work input either in the form of electrical energy or in the form of heat energy. So that will drive the system, and ultimately, eventually, we'll get the desired output, whether it is cooling or it is heating. So that can both can be achieved. So applications in particular, we can say that it can be employed at the spaces where large latent loads are there, like hotels, supermarkets, and auditoriums and pools, etc. So it can be easily deployed there. So as I mentioned, cooling technology, we have solid desiccant, liquid desiccant, and advantages of liquid desiccants over solid desiccants are the low regeneration temperature required in case of liquid desiccants as compared to the solid desiccants. So solid desiccants require little more temperature, maybe even more than 100 degrees centigrade is always required to get the desiccant material. Solid desiccant material get regenerated. Low air pressure draw with simultaneous cooling during dehumidification. So this is also a plus point of liquid desiccant air conditioning systems or liquid desiccants. And weak liquid desiccant can be stored during non-sunshine hours. So this acts as a storage also. So if we have like a weak liquid desiccant means the moisture content is more. It has absorbed the moisture, and it can be stored during the non-sunshine hours, and it can be circulated again in the sunshine hours so that it can be again regenerated to get it utilized. Now this is the water LIBR, lithium bromide absorption system. This is a single drum type, single effect you can say. This is a single effect system where we have, like in the conventional system, we have the evaporator, condenser, expansion device, and condensing unit. Likely in this case, we have the generator, we have absorber, and then we have condenser and evaporator are the same. Only the absorber and generator are there in place of these. Generator, we have where the heat energy we have to apply for the regeneration purpose. Okay. So heat is being given to the generator, and this is at high pressure. The solution is at high pressure. Then the vapor will be released and it will be condensed, and throttled means we are increasing the area and decreasing the temperature so that it is now available at low pressure and low temperature. Okay, least pressure in the system and least temperature in the system so that it can have the maximum potential to take up the heat from the space. So this is the evaporator. It is placed in the space which is required for the cooling or air conditioning. Okay. So like the indoor unit of any split air conditioning system, the indoor unit is the evaporator basically. So now it will pick up the heat from here, and the liquid phase will become converted into vapor phase. Then it will be going to the absorber. Okay, in absorber, heat is rejected, and additional cooling medium is required for that cooling. Okay. Then the solution is there is a solution heat exchanger in between, and it is again supplied to the generator where will be again utilized the solar energy. You can say in particular if we talk about the solar air conditioning, so we can apply the solar energy over here, or we can use any source of heat energy that can be used for the regeneration purpose. Okay. So likely this can be understood over here. This is a kind of drum, or within the drum, these are the sections where this is the like uh, these are the three units. Cooling water is supplied to this condenser. Then we have the generator. In generator we are using the uh, hot water, or heated water. That water is heated with the help of solar collector. That is being passed through the generator. That heat generator will receive the heat from the solar collector, and the moisture, refrigerant. Refrigerant means desiccant material that will be evaporated and will go to the condenser unit. In condenser unit, it will uh, come down to the liquid phase, and in liquid phase it will go when it is in the liquid phase, then it is again subcooled with the help of the expansion device or the heat exchanger. Okay, then it will have the least temperature and least pressure condition, so that it has the maximum potential to pick up the heat. Now this will be again going back to the generator. The weak solution will go back. The strong solution, this is the strong solution, will blue color solution. The strong solution will go back to the generator, so that it can take up. It can again circulate, be circulated in the cycle, so that the heat can be removed from the space that is required to be cooled. This is the double drum. In double drum, the additional set of generator and condenser is used. As in the previous case, we were having only this particular arrangement. So we have used the additional system so that we can have, like in case of like more cooling effect is required, we use the cascaded system. Cascaded means we have like combination of further compressor units are there in case of conventional systems. Likely in case of non-conventional systems, we use the additional set of condenser and generator in addition to the existing system, so that we can have the double effect to achieve the more cooling conditions. Like for the case of more load, like as I mentioned, the like the auditoriums or the hospitals or the supermarkets, they have more latent load as well as the sensible load. So there we have to go for the more cooling loads. So this is the comparison of ammonia water and lithium aqua ammonia, or another one is water lithium bromide absorption system. So these are the main two commercially available systems, as I mentioned in the starting also. So they are available commercially. So in ammonia, aqua ammonia absorption system, ammonia acts as a refrigerant, while water, or you call aqua, acts as a absorbent. So that will hold that refrigerant, and they are the mixture is made, that mixture is kept inside a drum, which is known as a generator. So in that generator, we will supply the heat energy so that it will evaporate the refrigerant. So ammonia will be evaporated once the heat is supplied to the generator. Okay, so it acts as a refrigerant. So the same principle is applied to the conventional system. So in that case, the refrigerant is being circulated with the help of the compressor. Okay, so the compressor pushes the refrigerant from the condenser unit to the evaporator unit. Okay, in between, there is additional arrangement of expansion devices, and then we have the heat exchanger to utilize the heat. Likely in the case of water lithium bromide absorption system, water acts as a refrigerant and lithium bromide acts as a absorbent. In this case, when the heat is supplied to the generator, where the solution of water and lithium bromide is stored or kept, the water will get evaporated and it will be going to the condenser, and it is further cooled, subcooled in the expansion device, and then it will be supplied to the evaporator unit so that it can pick up the heat from there and will be again back to the generator, and the cycle is again repeated. So aqua ammonia system, it operates at high pressures, while lithium bromide absorption systems operate at lower operating temperatures. And aqua ammonia They are suitable for refrigeration and air conditioning, while a lithium bromide system, it is suitable for air conditioning or heat pump. As I mentioned, both things can be achieved, heating as well as cooling. So if you want to go for both the systems, like all weather condition system, so we should go for the water lithium bromide absorption system. High generation temperature is required in case of aqua ammonia, but little lower regeneration temperature is required in case of water lithium bromide absorption system. Condenser is both water cooled as well as air cooled, but in case of what a lithium bromide system, only water cooling is required. Rectifier is required in case of aqua ammonia. Rectifier is used to like restrict the carryover problem. Like as I mentioned, there is a carryover problem. The refrigerant or the desiccant material goes along uh, in the cycle, or it has to be rectified. And in case of water lithium bromide, since water is used as a refrigerant, so there is no need of rectifier. COP in the aqua ammonia goes up to 0.6 only, but in case of water lithium bromide, it goes up to 0.8. Crystallization problem occurs in general in case of aqua ammonia, while in case of lithium bromide, it is a major problem. Okay, in aqua ammonia, there is no crystallization problem. Health hazards are associated as it is toxic and inflammable, while lithium bromide absorption system is non-toxic and non-inflammable. So this is the schematic arrangement of the system that we have developed at NIT Kurukshetra with the funding provided by DST SERB, and we have got the patent on this system also. So the components we have already discussed the previous slides. The main components are dehumidifier and regenerator. The process is basically atmospheric air is coming to the dehumidifier, and it dehumidifies the air. And as we discussed with the help of psychrometry, the moisture content is also to be little bit increased up to the comfort conditions. So it has to be passed through an evaporative. So we have got the desired output over here. But the additional setup, this whole complicated arrangement is provided to run the system continuously. Okay. So that is why we have provided the desiccant storage. There is a heat exchanger, solution heat exchanger. Then this is the regenerator where this desiccant material which is being passed through the dehumidifier, it will be stored here and then will be passed through the regenerator as per the availability of the heat energy. Now heat energy is coming from two sources. One source is we have in particular used the ETC, evacuated tube collector. In addition, the alternate arrangement of biogas is provided. We have used 2 cubic meter biogas plant, and the heat energy is stored in this heat exchanger. Actually, there is a hot water storage tank. That water is being stored. Hot water is supplied to the regenerator that will be used for the regeneration purpose. Okay, so additional cooling is sometimes required. For that, additional arrangement is provided. So this is the condensate collection at this point. This is the arrangement we have done. This is the mechanism I was talking about. From we have done some experiments with various configurations, and we arrived at this particular configuration where we have used uh, 5 channels, and each channel is having these bifurcations. They are made parallel flow as well as counter flow. So like the streams are flowing in this way, as you can understand with the help of this schematic diagram. Okay, so desiccant solution is flowing through these nozzles that we have provided over another side of this arrangement. Okay, in all the channels we have provided all the levels. Actually, these are the levels and these are the channels. So at all levels, the desiccant solution is made to flow in the form of film, and the air is made to flow in the counter flow and parallel flow in this way directions, and just to increase the residence time. Residence time is the time during which the air, that is the process air, that atmospheric air that is required to be what you call uh, dehumidified. Okay, so that should be in contact with for the maximum time in with the desiccant solution, so that it may get maximum moisture out of this atmospheric air. Okay, so now this air that is coming out of this whole arrangement is little bit hot but totally dehumidified. Okay. Uh, this is again the same mechanism. So we have provided some instruments to measure these parameters. Mainly we are dealing with the temperature and humidity. So these are the two main parameters. And of course, we have done certain experiments on with the variation of air velocity. So air velocity has also been increased or decreased or varied basically, and we have seen the effect of that air velocity. So this is the facility that we have created. This is the ETC, and this is the storage tank, and below it there is a biogas plant. It is not shown in this picture. Maybe in another picture it is visible. So this is the indoor arrangement. So this is a cold storage tank, and then this is used for the additional cooling required to be applied over the desiccant solution. Sometimes it releases heat also when mixture is prepared. The heat release is there. Exothermic reaction happens, and then this is the regenerator where the solution is regenerated. So we have done the pilot experiments on this facility, large scale, and these are the various steps that have been followed for the fabrication of the compact or level desiccant, liquid desiccant, solar power liquid desiccant air conditioning system. This is the final product. We have another pictures for this system. We have done certain experiments while preparing the solution, specific gravity and the concentration that it has been monitored, and for the weathering data, how much is the temperature conditions, weather conditions are there. So this weathering station is also there that has been used. So these are the results of the experiments that we have conducted on this multi-level uh, and multi-channel flat plate liquid desiccant dehumidification system using calcium chloride. So we have done experiments with calcium chloride solution and lithium bromide solution. Okay, so this is the inlet air relative humidity. So as we are dealing with the relative humidity only, then the sensible cooling is done with the help of additional evaporative cooler unit that I'll show you in the subsequent slides. So we have observed the significant reduction or significant reduction in the uh, moisture content from the atmospheric air, and we have plotted these different air velocities. As I mentioned, the velocity of the air is also varied. Likely the moisture absorption rate has been plotted, and this is dehumidification effectiveness. This is the inlet air relative humidity of the inlet air. This is a regeneration rate. Now this regeneration performance. Regeneration means how much is the availability of solar energy in particular. We have focused because we have named it as a solar liquid desiccant air conditioning system, though we have provided an alternate to the solar. Like in the non-sunshine hours, we can use the biogas for the heating of the water, so that the hot water can be used for the regeneration purpose. So the solar intensity has been varied, is varied actually. It varies actually from morning to evening, and we have plotted the efficiency of ETC, how much intensity and how much is the efficiency of the ETC is there. So this is in the almost same fashion, that is the availability of sunshine hours, solar intensity with time. So solar intensity, then hot water tank, inlet to the hot water tank, then outlet to the hot water tank, then regeneration tank. These are the temperatures that we have plotted. So they are also in the same trends, but the trend followed by the solar intensity. So it doesn't mean that we are totally relying on the solar energy. We have alternate arrangement, as I mentioned, to get the heat energy, so that the system may run 24 hours in the sunshine hours, also in the non-sunshine hours also. But this is the regeneration effectiveness that is plotted against the solar intensity. Regeneration effectiveness means how effectively we are regenerating the solution, how effectively we are able to get the moisture content from the desiccant solution, so that the desiccant solution can further be supplied to the dehumidification unit, so that it can dehumidify the processed air. Okay, this is the biogas plant, and the biogas is taken from this to this gas geyser basically. So this gas geyser is heating the water, and that water is stored in the tank, water storage tank. So this is the compact liquid desiccant air conditioner, as I mentioned. So one acts as a regenerator, another acts as a dehumidifier. This is a regenerator, this is dehumidifier, and dehumidified air is supplied to the evaporative cooling unit, and then we have both the cool and like air conditioned, like air conditioning, the terms I have mentioned for the comfort condition, that this much temperature and this much relative humidity that we have obtained with the help of this arrangement. These are the additional facilities that we have created at NIT Kurukshetra. This is my lab actually. I am the professor in charge of this lab, which is known as Advanced Thermal Engineering Lab. We have created these facilities with some internal as well as some external grants. This particular facility has been created to test the various biomass materials, specifically, as I mentioned, the crop residue, and we have done certain experiments on various types of crop residues to produce the useful fuel out of this waste material. So that fuel we have utilized for operating the engine in dual fuel mode. This is the engine that we have used. And this pipe is carrying that syngas, that was synthesis gas is cleaned, and this gas is supplied to the engine. This is variable compression ratio diesel engine with open ECU, and we were able to save to 58% diesel using this syngas in the dual fuel. So the pipe that is the port that is carrying the air from the atmosphere for the combustion, that pipe is being connected with this pipe that is carrying the same gas basically. So we have enriched the air that is being coming to the, and that is why it is known as dual fuel engine. So this is the another engine that we have dedicated on the gaseous fuels, and now we are testing this engine on the hydrogen fuel only. There is a provision of exhaust gas recirculation. This is single cylinder multi-fuel VCR engine, VCR diesel engine. This is petrol engine with open issue. This is engine test bed. This is steam turbine test rig. These are the other facilities. This is viscometer. This is data acquisition system. This is bomb calorimeter. This is exhaust emission analyzer. This is a complete list of the facilities that are created uh, last 5-6 years on NIT Kurukshetra, and the details are available over the website of the institute. And if somebody is interested, they can contact me for further details or further collaborations or further queries. Please contact me. Now, over to the organizers. If you have any queries, please.
Thank you, sir. And dear participants, if you have any query, any question where you discuss related to project, the platform is open for you. Please ask the expert.
Sir, other than this experimental things, any products available in markets, sir? New products related to with this technology?
As I mentioned that I am still sitting in the office where I am running this vapor compression system. So nobody has, as of now, adopted this technology. But since still there are chillers that I have already told you that chillers are already available, absorption chillers, which works on the same principle. But as far as the air conditioning is concerned, nobody has adopted this particular mechanism or the system as of now. Blue Star company has approached me previously, maybe 2 weeks ago, for having a discussion on the desiccant storage, the desiccant coating specifically. So we are in discussion. Let's see, something comes up.
You have registered any patent or intellectual properties, sir, with this
Yes, I
technology?
mentioned during the presentation also, sir, that we have got the patent grant on this particular
Like
technique.
for entire concept.
The concept.
Okay.
Sir, what are the major challenges to adopting these technologies?
Major challenges are the size actually basically, and the main technical problems as I mentioned is the pressure drop, as the air that is required to be work against some obstruction materials. So it has to pass through long channels. So there will always be a pressure drop. So that pressure drop has to be reduced, and otherwise there will be more work input requirement. And another important problem is the carryover problem. The solution goes away with the air if we increase the air velocity. So these are the technical challenges. Commercial challenges are the size and COP. The COP is little less as for the like if I talk about this particular room where I am sitting right now. So a 1.5 ton AC is installed in this room. So for cooling or air conditioning of this room, I need 4 times the size of the system. So that is the main challenge.
Thank you, sir. Participant, if you have any, please ask the experts.
Sir, how much time we can expect for retail sale of this technology-based products?
I couldn't follow you. What did you like? What is your point? Like, how much time is required for?
Like, how much time is expected to get these technology-based projects in a retail market?
Retail market, actually, it all depends on the companies. Maybe companies are working on, because the idea is in like in open. We have published research papers also. Now they can go independently, but they are still working on this thing. Maybe in year or so, you'll get this thing in the market.
Okay.
Sir, mainly regarding system with the renewable energy, what kind of challenging facing?
What renewables means? I really
Solar
did not
energy.
follow you.
Yes, sir. So during
Uh-huh.
configuration of this kind of system, so what kind of challenging faced with renewable energy sources?
What like configuration means?
System configuration, solar energy, voltage and
Uh-huh.
currents, all these systems, the related to
No,
configuration.
I'm not. No, we are not using at all the solar PVs. This is totally mechanical system, solar thermal systems we have used. And as I mentioned in the presentation, evacuated tube collectors are used because regeneration temperature is not much required in this system. Regeneration temperature up to 60-70 degrees C is only requirement. So that 70 degrees temperature can easily be achieved with the help of ETC. Even the flat plate collector can also be sufficient enough. Okay. In addition, we have used the biogas plant as you have seen in the photograph. So biogas plant is used to give the hot water supply during non-sunshine hours, so that the system may continue working for 24 hours.
Thank you, sir. Participants, if you have any query, please ask. Otherwise, we go to the conclude the session.
Sir, other than electricity, how much other resources is required, sir, like water or anything?
Like any source can be utilized, we need only 70-80 degrees centigrade temperature to heat up the water only. That is the only requirement to regenerate the solution.
No,
The,
this water.
the purpose is to supply the heat to the solution, the liquid desiccant solution, so that the water that has been absorbed by the solution during the dehumidification process, that can be released. That is the purpose only.
So
So
is this
any type of source can be used. Even the PV system can also be used.
no, other than this water heating, amount of water required, any continuous flow is required, or
No. Continuous flow is not required. The water once stored in the tank, that will be recirculated again in the closed cycle, so that the little bit makeup water is required. That is very less quantity that we have observed during the experiments.
so no treating of water is required, sir?
Note?
This treating of water is not required.
No, not at all. Because this is the separate cycle. This is not in the direct contact with the solution. This is in indirect contact.
Okay, thank you.
So thank you everyone for your active participation for today's insightful sessions on non-conventional air conditioning system approach towards the net zeros. delivered by Dr. Rajneesh, sir, Assistant Professor NIT Kurukshetra. And in his presence, discussed about the various types of including the solar assisted evaporative cooling and absorption chillers. And he highlighted the potential to reduce the energy demands, enhance thermal comforts, and contribute significantly to achieving the net zero buildings. The session is also addressed the key configuration challenges such as the system integration with the renewable energy sources and design adaptability, while outlining the advantage of architecture. So we are grateful to Dr. Rajneesh for sharing his valuable expertise, and thank you all the participants for the interactive work. So we look forward to see you in the upcoming sessions of FDP at evening 4 p.m. So thank you everyone, and thank you Rajneesh sir for the delivering nice session.
Thank you, Dr. Ravi.
Thank you so much. Obviously, at the session, close the session. Thank you everyone.
Thank you.